So every equation that we solve is going to have two different types of terms. Now, no matter how many terms the equation has, 1, 2, 3, 4, 5, 6, doesn't matter. We're going to build up to a bunch of different terms. They're going to fall into one of two categories always. Variable terms, or terms that contain a letter, and constant terms, which are only numbers. So you've got two colored highlighters in front of you, hopefully right now. You're going to commit one of those colors is going to be your variable term color, and one of those colors is going to be your constant term color. I'm going to highlight my variable terms in yellow and my constant terms in pink. So whatever two colors you have. And some of those highlighters are kind of dark, and make sure you can still read what's underneath it. Especially the blue and the purple tend to be a little darker. You guys got to pass out your highlighters to your group. Yeah. Come on. Variable terms are going to look something like this, either 2x, negative 4y. Oh, that's a really ugly yellow. Kinda, not enough. Two x, negative 4y. Z x over 3. Those are all variable terms. What do all four of those terms contain? A variable. Pretty straightforward, right? Constant terms are just constants. What does it mean for something to be constant? Over and over, repeating, or the same, right? If I have a, we've already talked about constant. So constant means the same. So a constant term would be something like 2, negative 10, 1/2, 4. What do all of those four pink terms have in common? No variables. They're just numbers. Right? So what z is equal to depends on the equation. Z could be equal to anything. Right? It's variable. It's changing. But 2, that's always going to be 2 no matter what. It's constant. So constant terms are just numbers. Variable terms are any term that contains a letter. It could be just a straight up letter like Z, or it could be a letter with a coefficient like 2x. Just to review here, what would my coefficient of Z be?
1.
1, exactly. Whenever we have a variable all by itself, we know there's a 1 in front. That's going to be super, super important for us to remember today. That little invisible 1. Those are our two types of terms. No matter what our equation looks like, we're always going to have those two types of terms. If you look back at our worksheet from yesterday, I've got a variable term and a constant term. Here I've got two constant terms and a variable term. Z over 3, variable term. 7, that's a constant term. The reason why it's important for us to understand the difference between these two is because we can only combine like terms. If you and your best friend are super alike, what does that mean? What would it mean for you and your best friend to be alike? Y'all don't got best friends? What does it mean? If you and your best friend are super alike? Just in a simple sense, what does that mean? Compatible, yeah. You have a lot of things in common. There we go. Had to lead into it. It's early. I get it. So all of these terms have something in common. They contain a letter. These are like terms with each other. And all of these terms have something in common. The fact that they're just numbers. These are also like terms. So when we're talking about like terms, we could say like terms. I'm going to say the word terms like a million times today, so I apologize. Like terms are terms that fall into the same category. Either variable or constant. Those are the only two categories we're going to deal with. Some examples of like terms. Would be, let's see, 2x and 4x. They're both variable terms, and something that we're going to mention in a second is that they have the same variable. Some other like terms would be 3y and negative 5y. Go ahead. Both variable terms, both contain the same variable. We could also say that like terms are 5 and 1. Those are both constant terms. If we were to combine 2x and 4x, what would we get as a result? 6x, right? 2x and 4x makes 6x. What's that? You say we should multiply the 2 and the 4? Yeah, if we're multiplying them, yes. But when I'm talking about combining, that means adding. Yeah, we'll definitely be multiplying them too. But if we want to combine 2x plus 4x, that makes 6x. What happens if we combine 5 plus 1? What do we get? 6, thank you. 5 plus 1 gives me 6. What do we get if we do 2x plus 1? What does that make? Does it make anything? No, we can't add 2x plus 1, right? Those cannot be combined because they're not the same category. One of them is a variable term, one of them is a constant term. So the opposite of like terms would be unlike terms. If we've got 2x and 4, those cannot be combined because they are not in the same category. If we have something like negative 3x and 4y. Mr. Church, those are both variable terms. But what don't these two terms have in common?
Oh, the variables?
The variables, right? It's fine if one of them is negative, right? Like we saw over here. We got positive 3y, negative 5y. That's fine. But an x and a y cannot be combined, right? That's like saying these are two best friends. One likes country, one likes rap, right? You don't have a whole lot alike, not a whole lot in common. Probably not going to mesh together. I mean, you might, but you know what I'm trying to say. Can't combine them. Different variables. So let's add that in here. Cannot combine different variables. Super important for us to understand as we start building and building on these ideas. And something like negative 1 and z, right? Those are definitely unlike terms. One's a constant, one's a variable. Like terms can be combined. Unlike terms cannot be combined. And when we're talking about combining, we mean adding or subtracting. Yeah. When we're done with notes. So if we want to combine two variable terms, all we got to do is add or subtract the coefficients and keep the variable the same. Like we said, 2x plus 4x gives me 6x. We add the 2 and the 4 to get 6, and we keep that variable the same. For example, if we have 2x plus 4x, go ahead and highlight that 2 and that 4. We're going to bring them out in front and add them together. Keeping that x on the end so that it remains a variable term. What would 2 plus 4 give me as a new coefficient again? 6. Keep that x right there on the end. That's combining like terms. (2x plus 4x gives us 6x. 3y plus 4y would give us 7y. And so on, just like that. So now we're going to add this little element into exactly what we did yesterday with our inverse operations, crossing out the equal sign. Now we're going to have to also combine like terms first. I'm going to flip this over just to have a lot of space to get going, so I'll give you a moment to finish copying that down. Definitely keep your highlighters out, though. It's going to be part of our homework as well as highlighting. All right. Let's take a look at our first example of how we're going to do this. Let's say we've got 3x plus 5x equals 16. First thing we want to do is combine our like terms. But in order for us to do that, we got to figure out what terms in this equation are alike. Just like always, we want to split our equal sign first. Doesn't matter what we're doing, that's the first thing we always do. Because we can only combine like terms on the same side of the equal sign. So with our highlighters, whatever color you chose for your variable terms, you're going to go and highlight each of our variable terms. We've got 3x, 5x, and 16. Which of those three terms is our variable term? 5x and 3x. What's my constant term here? 16. So our variable terms, mine are in yellow. Our constant term is in pink. This is so that we can visually see what we can combine and what we cannot combine. We can only combine two terms of the same color. Bless you. So if we want to combine these like terms, like we said previously, we're going to add or subtract the coefficients and keep the variable the same. What are my coefficients for these two variable terms? What are the numbers in front of my x's? 3 and 5. So I'm going to take 3 plus 5x, and that's going to be equal to 16. Right? If I have 3 x's, you have 5 x's. In total, how many x's do we have? If you have 3 and I have 5. 8, exactly. We're just adding 3 plus 5 to get 8x equals 16. Now we can go back to what we talked about yesterday and solve for x. So like I said, every new lesson this unit, we're just adding in little elements every single day. But when it comes down to it, we're getting right back to our foundation that we laid in 7.1a. What am I doing to x right here? Am I adding 8? Am I subtracting 8, multiplying 8, or dividing by 8? What am I doing with this? Not what do I want to do, what am I currently doing? Multiplying. So the opposite of multiplying would be to divide. That's right. We're going to cross out. Dude, I'm like not ready to be here, but that's okay. We're going to cross out our 8s. Boom, because 8 over 8 is just 1. What are we left with on the left-hand side?
16 over 8.
On the left-hand side.
Oh.
Left like that. We got x. Now we can simplify the right. What is 16 divided by 8? 2. Boom. There is our answer. X is equal to 2. Solve using our inverse operations, just like we did yesterday, once all of our like terms are combined. So we can even see now we've got that 8x, one single variable term, and one single constant term. That's how we know we're ready to solve. Because I'm going to go back. You can add this on to the end after that example, but I forgot to mention something extremely important that we need to get down. This is super, super, super important for us to remember. In fact, I'm going to put a cloud around it. You can only combine like terms that are on the same side of the equal sign. I went back to the first page, but I said you could just add it on the end of that first example. Like after this, you could put it after that if you have space. I went back back because I had some room. What I mean by that is this. If we look back at our homework from yesterday, right? On the left side, I've got a variable term and a constant term. And on the right side, I've got a constant term. I can't just combine negative 4 and 4. They're on opposite sides. The only way that we can combine these two is by using inverse operations like that. Anytime we cross over that little invisible line, we have to do the opposite. But if they're on the same side, like this, we just add them together. I know that's a little bit confusing, but if you have a question about that, let me know. We're almost done. Dang, I did a lot. Okay, we're going to do... Say go back? Okay. All right. If we still need that, I'll come back to it at the end. We got to get cracking on these examples, though. Let's say we've got let's do 7y minus 3y plus 2y equals 36. Seven y minus 3y plus 2y equals 36. Who could help me out? What's the very, very, very first thing we want to do here? Devin?
Draw a line.
Draw a line through the equal sign. That's right. I need to know what's my left and what's my right because I can only combine on the same side.
Oh,
Yeah.
left is 7y.
Yep. What are my variable terms on the left side, Darius?
Right there is 7.
7y. What else?
Negative, 3y.
-3y. Good. What else?
And plus 2y.
And a 2y. Exactly. What are my constant terms here?
36.
36. And that's on the other side, which is great. There's nothing we can combine with that 36 anyway. So here I have three coefficients. We've got 7, -3, and +2. We're going to bring all three of those numbers out to the front. 7 minus 3 plus 2. And that's going to go in front of our y. 36 is untouched. We've got a 7, a -3, and a +2 out in front. I'm going to pause here for a second, make sure you see what we did there. Just like we did in the previous example, but with an additional term to add in. Now we've got to solve what's inside the parentheses. What is 7 minus 3? 4. What is 4 plus 2? 6. So we've got 6y equals 36. We combined all three of those variable terms into one single variable term. If I've got 7 y's and I take 3 away, I've only got 4 y's. But then I add 2 more y's and get 6. Right? Just simple addition, subtraction. Now that I've got one yellow term, one pink term, I can solve this out like normal. What am I going to have to do on both sides here if I want to get y all by itself? Divide by 6. Exactly. What happens to 6 over 6? Cross them out. We get y is equal to 36 over 6, 6. While you're finishing that up, quick show of thumbs up if this makes total sense. Thumbs sideways if it's making a little bit of sense. Okay. Good. Understand the sideways thumbs. It is a little bit tricky. We're going to get tons of good practice with it today, though. One last example, and then we'll get started. Let's say we've got (5m minus 2m plus 3 equals 24. Will that work?
Yeah.
I love the confidence. I'm sure it will. What do we do first? Draw the line, exactly. After we draw that line, we got to figure out what we're working with. That's where our highlighters are going to come in. What are my variable terms here?
5 and 3.
5m.
5m, does 3 have a variable on it? No. But what does?
2m.
Negative 2m. What are my constant terms?
3 and 4.
3 and 24. So if we notice, if we look back to our highlighting on the previous two examples, this one's slightly different. Why? What's different about this one?
Not all of them have a variable.
What's that?
There's one there. What's it called? The constant is on the side.
Good. There's a constant on the left-hand side. See up here, our only constant was on the right. Our only constant was on the right. But now we've got a constant on the left. We'll take care of that in a little bit. But let's stick to what we know how to do. And let's combine these like terms. We've got 5 and negative 2. We're going to bring those out in front. 5 minus 2m plus 3 equals 24.
You don't add the 3 to the left.
No, we do not bring that 3 in there because it's not the same term. Or they're not the same type of term. We got to leave it. We're going to subtract it over to the right here in a second. But we want to combine these like terms first. This is why we're highlighting, so we don't accidentally combine all those 3 terms together. Right? We can only bring together the same color. Just like here, just like here. So what's my new coefficient for m? 5 minus 2? 3. M plus 3 equals 24. Now this looks just like the problems we were doing yesterday. two-step equation. If I want to get m all by itself, what can I do first? Subtract 3 just from the left, from both sides. Minus 3, minus 3. What happens with this plus 3 minus 3? Cross them out. Beautiful. And what's 24 minus 3? 21. So my new constant term on the right is 21. My sole variable term on the left is 3n. Last thing I need to do is what? Divide both sides by 3. What happens with these 3's on the left? Cross them out. And we get m equals 21 over 3. 7. Nice and easy. Boom. There is our final answer. Any questions on how we arrived at 7?